Nope, they said the last one. All right, so the last one is a policewoman has positioned herself 500 feet from the intersection of two roads. She has carefully measured the angles of the line of sights from point A and B. As shown in the drawing, if a car passes from A to B in 1.75 seconds at the speed, and the speed limit is 55 miles per hour, is the car speeding? Hint, find the distance from B to A and use your normal rate distance over time. So I'm going to take a picture and I will go over what I did. All right, so pictura. So my whole goal is to get this distance. Because if I have this distance, I already have the time. I just need this distance because I already have the time of 1.75 seconds, so I need this distance. Well, the only way we know how to find the distance of a triangle is if we have a right triangle. So I drew two triangles. One is basically, maybe I'll write on here, this triangle right here is all the way to A. So in other words, the top triangle is this triangle here. That is that triangle. Because I want to get this entire distance. So I'm going to get this entire distance, and then I'm going to subtract away this entire distance. Because if I take the long distance and subtract away this one, I'm just left with from A to B. So this is the top big triangle, and the one right below it is this triangle here, from this corner to B. Like I said, if I take the big distance, subtract away the small distance, I'm left with A to B. Well, we are told the angles of both of these being 15.4 and 12.3 on here. And we also know the base was 500 feet. So I'm looking for something across using this base, which is adjacent. So across adjacent tells me to use tangent. The tangent of this angle equals opposite over adjacent, which is my distance 1 divided by 500. The same thing goes for my second triangle. The tangent of 12.3 is going to equal my distance 2 over that 500. So I didn't write that on there because I just kind of did it in my head, but what really we had was tangent of 12.3 equals my second distance divided by 500. Both these work out to something I can plug in my calculator, and the big distance is 137.7 feet. The smaller distance is 109. So the distance between them, which is our A to B, that's why I circled it and put it here, is 28.7 feet. So in 1.75 seconds, that car moved 28.7 feet. So I put it in our rate equals distance over time, like miles per hour. Distance over time. So I had 28.7 feet over 1.75 seconds. Then all I had to do is convert it to miles per hour. Well, there's 3,600 seconds per an hour. You also could have did 60 per minute and then 60 per hour. I just like the 3,600 seconds per hour. And then there's 1 mile per 5,280 feet. Make sure stuff's going to cancel out. Like make sure if I have seconds down here, I have seconds on top. I have feet here, so my feet would cancel out here. And I'd be left with miles per hour, which results in 11.2 miles per hour. Obviously, they're not speeding. If anything, they should be arrested for going too slow in a 55, because that'd be pretty annoying.
That cop can do math pretty quickly. Well, maybe they're
Oh, she's good. I know. Maybe they're making a right-hand turn. They're slowing down.
Also, don't they have like a thing that tells them how fast people are going?
A radar?
Yeah.
Yeah. Did you know cops actually do use this, though? They have spots around the city that they know the distance of how long it would take them to go. They're not actually using triangles. They're just like, okay, they have like landmarks where they say, okay, if it takes them faster than 10 seconds to get from this landmark to the other landmark, they're speeding.
I got a ticket for speeding.
Good job, Bree. How fast were you going?
16 over.
Ooh,
Wow.
that's kind of traditional on Capitol, though.
It was on Lennon.
Okay. I was saying, on any highway or something around Milwaukee, it's always like 15 over, it seems like. If you're going like the speed limit, people are just like flying past you on highways and interstates here.
And I feel so like out of place when I go faster.
All right, any questions of how I did this problem? Mike, did that make sense when I went over it? Okay. Other questions on the homework? No.
I just gotta make a clarification.
Yeah.
How do you know, I know, okay, so can you clarify number 41?
Sure. Let's start there. Let's start there. All right, what do you need clarification on, I guess?
All right, how do you set it up to figure out that you need to get tan? That was...
So I guess without the picture, it might be a little tougher. But I think our key words are, so an aerial photograph of a U-2 spy plane, the photograph is made when the angle of elevation, so the first thing I'm looking at is angle of elevation is 32 degrees. Angle of elevation is always going to be the one looking up. So I know if I have a right triangle, I have a 32 degrees here. Then by comparing the shadow cast by the building to objects of known size, so we're talking about a shadow. We're talking about a shadow that basically we have a building. This can be a pretty sweet building with some nice lights, right? And our shadow would be kind of down here, right? So they're talking about the length of that shadow and the height of the building. They're saying they see the shadow. They know how long the shadow is. They want to know how tall the building is. So we have angle of elevation. We have length of shadow, which would be that 80. We're just looking for the height of this building.
Okay.
So I would just fill that information in and say, well, height is opposite that 32 degrees, and this is adjacent, so it's opposite over adjacent.
Okay.
I think the key to these problems is drawing your right triangle and not getting bogged down in, should I use sine or whatever? Just draw your picture and say opposite. If they give you the hypotenuse, then we're using cosine or sine. Yeah. Other questions? All right, we do have a test tomorrow. You have a review. Solutions to the review are online. I also have solutions somewhere floating around here. I put them somewhere. I can find them. So you can check your answers. Do your best to get this done. I don't collect it. Your best thing is I'll know you did it because you'll do better on the test. I do write the review after I write the test, so a lot of these problems are similar to stuff that's on the test, but it doesn't mean that everything is on this review that you need to know. This is just the basics. It guides you to go to what lessons you are weak on. So say you get to a problem, you're not sure how to do it, review that whole lesson and review lots of problems on that stuff. All right? Also, and I'll say this a million billion times, the review is not a test. So I'll see a lot of you doing the review with a closed notebook asking questions. A review should be done with your notebook open, looking at those lessons, learning the material. All right? It shouldn't be a test to see if you know the knowledge. And it shouldn't be, well, my only resource is to ask questions. Your first resource should be your notes. See if you can learn it from that. And then if you have more questions, then ask those questions. I'm more than happy to answer questions. Makes my day actually go quicker, but I want you to be self-reliant, that you can find this stuff in your notes, you can read the stuff, you'll learn it a lot better than me pointing out your mistake or something. All right? Second thing is just a reminder on, what would that be? We have test tomorrow. On Thursday, bring your PSAT packets. Because we're just going to have a PSAT work period. We're required to give you that before the PSAT. All right, otherwise the rest of the time is yours to work. Work hard as